Hello, my YouTube viewers. Today I will present you this asymptotic notation of this time complexity. Then please watch every detail until the end. And if you have comments, write me on the comments. And then also like, share, subscribe to your friends. This is supporting me. Thank you for everything. ሄሎ ተመልካቾቻችን፣ ስለዚህ ዛሬ የማቀርበው አሲምፕቶቲክ ኖቴሽን ላይ ታይም ኮምፕሌክሲቲ ካልኩሌሽን ነው። ስለዚህ በጥሞና እንድትከታተሉና ጊዜያችሁን ሰጥታችሁ እንድትከታተሉን እየጠየቅኩኝ ያው እንደሚጠበቀው ላይክ፣ ሼር፣ ሰብስክራይብ እያደረጋችሁ ኮሜንትም ችግር ካለ ኮሜንቶችንም እየጻፋችሁ እንድታግዙን እንድትደግፉን እላለሁ። መልካም ጊዜ። Question number 1, what is the time complexity of the following function? The function given below, int count, and then int k is equal to 0, c out, enter an integer, c in n, then there are the for loop, I is equal to 0, I is less than n, then I plus plus, then k is equal to k plus 1, return 0. This is a function. A big of n square, B big of n log n, C big of n, D big of log n. The correct answer is C, big of n. Here, when you see the function, here int k is equal to 1, this operates 1 unit, that means big of 1, it operates complexity big of 1, and the other one is c out, also it operates 1 unit, and then this is also big of 1, and this c in also it operates 1 unit, and then this is big of constant, it's 1. The other one is for loop. Here there are in the for loop there are here initializations. This initialization run is only one time, because of this big of 1 unit. The other one is the test I is less than n. This operates n plus 1 times, and then because of this is when you time complexity big of n. The other one is the increment operators, and then these increment operators it's n times, and then the running time big of n. The other one in the body there are k is equal to k plus 1. This operates equal sign operates 1 time, plus sign operates 1 time. When you see this is 2 times, but this depends on I plus plus, depends on this increment, and because of this operates 2 times n, and then with the running time big of n. The last one, this return statement also run only one time, and then this is big of 1. When you see overall operations, the maximum is big of n. If you add is the running time or the time complexity is big of n. That means linear operators, linear functions. It's a linear function. Because of this, big of n is a linear function. That means the for loop only operates a single loop, single loop. And the other operators, the other options, option A, that is incorrect. That means big of n squared. This is the quadratic. Then when you analyze, there is no any option to see the quadratic, because this is the single loop iterations of n times, where n is an input integers. The other one is B, also big of n time log n. That also, that represents is a logarithmic, but these logarithmic operations, especially for merge sort and quick sort in the divide and conquer approach, but this one is not the quadratic, because logarithmic, because this is linear. The option D, this is big of log n. Then also this also is a quadratic time complexity. This is especially used for binary search operations. This is also incorrect. Question number 2. What is the time complexity of the following function? Here, int total, int n, int sum is equal to 0, then for brace int I is equal to 1, I is less than or equal to n, I plus plus, and then sum is equal to sum plus 1, then finally return is equal to return sum. Then the options A, big of n squared, B, big of n, C, big of n cubed, D, big of 1. The correct answer is B. The correct answer is B. The analysis here, a function. In a function, the function name is total. Then here in the body, sum is equal to 0. This is operates 1 unit. And then this one is big of 1. The other one is for loop. Here in the for loop, this is this for loop, it operates 1 time, and then big of 1 running time. The other one is I is less than or equal to n. This operates n plus 1 time, and then because of this, the running time is big of only n. The last one is the increment. This increment also is operates n time, and then this is big of n. The other one, sum is equal to sum plus 1. This operates 2 units because equal sign 1, the sum is 1. This is 2 times, but this function, this summation, basically depend on this I plus plus. This I plus plus is n time. Because of this will be 2 n times. Big of 2, big of, this is big of n. When you see, the last return, the return operators 1 unit. It operates 1 unit and big of 1. Overall, there are big of n, this big of 1, big of n. Because of this, the running time or the time complexity of this function is big of n, because it operates a single loop. Okay. The other options, option A, big of n squared. This option suggests the time complexity of big of n. This implying that the function performance grows quadratically with the input size. However, the functions only contains the single loop that iterates n times and performing constant time operations within each iteration. Therefore, the correct time complexity is not the quadratic one, because as we seen the above, big of n, that is linear. The other option C, also this is cubic functions, and then on the above, this is big of n, it's a linear, totally that is not cubic functions. The other one is D, big of 1. This is a constant function. This is not totally a constant. This is a linear. Question number 3. What is the time complexity of the following function? The function int count, then int k is equal to 0, c out enter an integer, c in n, and then for loop I is equal to n, I is greater than 0, I minus minus is a decrement, then k is equal to k plus 1, then return 0. The option A, big of n square, option B, big of n, option C, big of n cube, option D, big of n. The correct answer is B. It's a linear function. As you see in the previous, it is similar. It's one time. This is big of 1. The other one, this also is operates one time. This means big of 1, constant time. This one also operates one time. This is big of 1 time. The other one is here in the for loop. In the for loop here, I is equal to 0. I is equal to 0 is similar. This is also, it operates one time. This is big of 1. This is I is greater than 0 is also n plus 1 time. And then this one is also big of n. The other one, this is decrement, is similar with the previous one. The previous one, it starts from 0 to n, but this is the reverse one, starting from n to 0. That is only the difference. Then here, the decrement, this also, it operates n time, and because of this, big of n. That means when you see this, the for loop, here is 1, this is 1, plus, this was n plus 1, n plus 1, the other one is n. Overall, the maximum one is big of n. Big of n is, no, n plus 1, and then for this n plus 1, this is the running time is big of n. And this one also similar, it's 2 times, but this is depend on the n. This is 2n times. And the running time or time complexity of this function is also big of n. And this is also constant, big of 1. And based on this analysis, the total or the maximum or the worst case of time complexity is big of n. The answer is B. Question number 4. What is the time complexity of the following algorithm? there are a for loop for I is equal to 1, semicolon, I is less than or equal to n, semicolon, I is equal to I times 2. There are the brace, the opening brace, k is equal to k plus 1, and the closing brace. A, big of n square, B, big of n times log n, C, big of n, D, big of log n. Okay, before talking about the answer, we need to go to the detailed operations. Here, in the for loop, here I run from 1, this I is less than or equal to n, this I is equal to I times 2. Here in this equation, for example, this here I almost operate once or in one time. Then, but here this k is equal to k plus 2. It's operators based on this the test and the incrementers. In this option, for example, here, for example, the first one, this is I less than or equal to n. Then here there are increment. I is equal to I time I time 2. Here when you see, for example, here I is 1, this is 1, this 1 less than or equal to n, and then after that, after this operate, and then the loop return back to this I. Here I is 1, here is I is 1, 1 times 2, then this will be how much? This is 2. Then after that, this 2 less than or equal to n. Then after that, here this I is 2, 2 times 2, 2 times 2, it will be 4. This I is changed to 4. And then here this 4 less than or equal to n. Then here this 4 times 2, 4 times 2, this will be 8, and this I is changed to this one. It's go to like this one. Then here similar. When you see here, this is at the first I, this is I. When it's 1, this is 2 the power of 1. This when you say 4, this is 2 the power of 2. The third one, 8, this is 2 the power of 3. When you continue, for example, if it is 8, 8 times 2, this will be 16. Then also this is 2 the power of 4. Based on this, this is the value of k. 1, 2, 3, 4. Based on this, when you see this one, for example, these operations, this is 2 the power of k. This is equal to what? 2 the power of k is equal to, or no, less than or equal to n, based on this. And then when you see here, to the power of k less than or equal to n, when you remove less than, this is to the power of k equal to n. Based on this, what it shows this one, this is the log of, this is log n, log this log base 2 log n. And based on this, the time complexity of this algorithm is the time complexity is equal to big of how much? Log 2 n. Based on this, the answer is D. Based on this, the answer is D. Question number 5. What is the time complexity of the following algorithms? An algorithm is the nested for loop, and option A, big of n squared, B, big of n time log n, C, big of n, D, big of log n. Here there are for loop. This the upper for loop and the inner for loop, or the outer for loop and the inner for loop. Those two for loops are independent, cannot depend one, or the inner one cannot depend with the outer one. That is independent. If it is independent, the summation of the two loop will be the time complexity of an algorithm. Based on this, here is 1 operates one time. This is n plus 1 for the second one. The increment, this is n times. Based on this one, the maximum, the time complexity of this equation is the highest order. The highest order is n plus 1. N plus 1 is the highest order for the outer one. And because of this, the time complexity is removing this one is big of n. This is n plus 1 time. The inner one also independent is similar. Here is 1. For this one, n plus 1. N plus 1. For this one, the increment is n times. Similar, this is n plus 1 times. And because of this, this is big of n. This is nothing. This one is depending on the operation of this one, because this plus 1 is, it is false. That the iteration cannot move to k is equal to k plus 1. It will stop. And then based on this, the time complexity of this one is the summation of those two. That means n plus n, not the summation, multiplication, the multiplication of the two. Because of this, big of n plus n, that means big of n square. Based on this calculation, the answer is A, that is quadratic. functions. Question number 6, what is the time complexity of the following algorithm? It says an algorithm I run from 1, I is less than or equal to n, this I plus plus, and the inner loop or nested loop, the other j is equal to 1, j is less than or equal to m, this is j plus plus, and then the addition k is equal to k plus 1. The option A, this is big of n squared, B, big of n times m, C, big of n, D, big of log n. Question number 6, what is the time complexity of the following algorithms? There are similar with the above, but the difference is the first one, this I less than or equal to n, the inner loop j is less than or equal to m. Only this one is the difference. But here it's m, n, here the inner one is m. Like the previous equation, similar. And then these two, the inner one and the outer one, also independent. One equation cannot dependent on the other one. And based on this, it's similar. Here it operates 1. This is similar, n plus 1. And this iterates n times. And based on this, the maximum time complexity of the after one is n plus 1 time. N plus 1 time. The inner loop also similar. This is 1. This is n plus 1. And then for this one, n times. And then this is m plus 1 time. Because this is, sorry, this one is m, then this one is m, because it depends on the value of m. M plus 1 time, this m times, this is m plus 1 time. Okay, based on this, the time complexity of the first one, and for the second one, this will be m. That means big of n, big of m. And then based on this, when you multiply these two, this is big of n times m. That is the time complexity of this algorithm is big of n times m. And based on this, the answer is B is the correct answer. Question number 7. What is the time complexity of the following algorithms? Here, an algorithm is a nested for loop, but its nest is two nests, because the outer one for loop I run from 0, the inner loop j equal to 0, the third one, the inner within a j, k is equal to 0. Option A, big of n squared, B, big of n cubed, C, big of n, D, big of log n. The question number 7. In this equation, there are three for loop. It's a nested loop, and based on this, we will see how we will get the result of this the algorithms. The three equations. The first one, I run from 0 to n. The second one is j run from to n. The third one, k run from 0 to n. Then these three equations are independent. If it is independent, each of the block will compute individually. For example, based on this, as a previous, the result for the first equation, this is the time complexity for this one is n plus 1 time. And the second one also similar. That means j run from 0 to n is also similar. This is also n plus 1. And the third one also, this also independent, is similar. This is n plus 1. N plus 1. Finally, when you compute this, if it is a nested independent, the result will be the multiplication of the 3. For example, for the first one, here is n plus 1. That means removing this 1. This is big of n. The second one also n. Sorry. Okay. And this one also n. The third one also n. And based on this, the time complexity of the 3 is the summation of the 3. The big of n time n time n. And based on this, big of n cube is the answer for this question. Based on the result, the answer is B, big of n cube. Question number 8. What is the time complexity of the following algorithm? For I run from 0, I is less than or equal to n, I plus plus, and the other one is the nested loop. For loop, this is j is equal to 0, j is less than or equal to n, and j is equal to j times 2. And then sum is equal to sum plus I. Based on this, there are the choice. A says big of n square, B big of n cube, C big of n, D big of n log n. The question answer before that one, we need to compute each operation. In the first one is in the first one for loop. These two loops are also independent, and then because of this, for this one the running time is n plus 1. That means n times the second one, j run from 0 to j less than or equal to n, j is equal to j times 2. Based on this is log n. Based on this one, these two for loops are independent, then we will multiply both one. Here, this is n time log 2, log n. This is the big O of n time log n. Based on this result, the correct answer is D. The correct answer is D. Question number 9. What is the running time of the following fragment of algorithms? There are a for loop for I is equal to 0, I is less than n, I plus plus, and then within a brace k is equal to k plus 1. The other for loop for j is equal to 0, j is less than n, j plus plus, within the braces sum is equal to sum plus I. Sorry, sum is equal to sum plus 1. The options A, big O of n squared, B, big O of n cubed, C, big O of n, D, big O of n log n. When you come to the answer, here there are an options. Here there are for loop, but this for loop is not a nested one because this is one for loop, this one is another for loop, is independent. Then also it is not a nested one. Based on this, individually, when you compute, you will compute the first one, and then after that you will compute the second one, and then these two for loop is not nested. If it is not nested, the summation of the two will be the answer. Based on the first one, I run from 0, I is less than to n, that computes the maximum of n plus 1 time. N plus 1 time. That means big O of n. And the second one also similar. Then also n plus 1 time executes n plus 1 time because this one executes n plus 1 time. This is n time. This is 1 time. And then the maximum is n plus 1 time. Then based on this one, the result also similar, big O of n. And then if these two for loops is independent, if it is not nested, and then this will be the summation of both. That means n plus n. That means big O of n plus n. That means big O of 2n. And then the coefficient will be removed, and the final result is big O of n. Based on this answer, the result will be C, big O of n. Question number 10. What is the runtime of the following fragment of algorithms? Then there are the nested for loop, and then there are the for loop. I run from 0 to I to n, and then I is incremented by 1. The inner loop, j run from 0 to I, that j incremented by 1. And then the statement sum is equal to sum plus 1. It's a nested for loop. Option A, big O of n squared. B, big O of n cubed. C, big O of n. D, big O of log n. Okay, when you see the result, there are j, no, sorry, not J, I. Okay, here is I option, and the other one is I less than N, the other one J option, and J less than I. Again, the result or statement or operations. Can I say operations? Operation. And then that means the number of operations. When you see I is 0, I is 0, 0 less than N, and then immediately the operation move to the inner loop. The inner loop J is 0, and then this is 0 less than I is 0, and then this statement will be false. This statement will be false. And then after that, this operation cannot be performed. And then this cannot be performed 0 times. The operation 0 times. Number of operations. Sorry, number of operations 0. Okay, and then I is incremented. I is incremented. I will be 1. This is I. 1 is less than N. And then J is still 0. 0, 0 less than I is 1. That is true. And then it's executed. This one, then J is incremented. J is 1. 1 is less than 1. Then this will be wrong. How many times this statement operates? Again, 1 time. 1 time. Again, the loop back to the outer loop, and the outer loop, when I is incremented, I will be 2. Again, 2 is less than N, and then J is still 0, but no need of this one. Here, J is 0, 0 less than I is 2, that is true. Sorry, true. Again, J is incremented. Again, 1 less than 2, then also true. J is incremented. You see, this is executed. Again, 2 is less than 2. Again, this will be wrong. How many times? This executes 2 times. This and this one. Again, 2 times. When you see this one, here I from 0 to N, that means it's moved to until N. Think until N. And this operation also will be moved to N times. Based on this, these operations, how many times, the running time of this one, because this is dependent. Based on this execution here, nothing, here 2 times, then here, no, sorry, this one is 1 time, and then here it's executed 3 times, sorry, 2 times, this 2 times. If it is 3 times. Again, what is the running time of this one? That means the summation of this one, here 1 time, here is 2 times. Based on this one, the total operation will be the summation of this one. That means 1 plus the first 1 time, again here 2 times, again here 3 times, like this, move to N times. That means the summation of a number, the execution, number of execution from 1, not only from 1, from 0, because it executes nothing here. But this means with a formula n times n plus 1 over 2, because any numbers, the summation of any number from 1 to n will be n into n plus 1. And based on this, the functions, no, the running time of an algorithm is, the running time of an algorithm will be, this is, when you remove this one, n square, because this is, when you see this one, n time n plus this n, this is how much? N. That means here half, then here half. That means big of n square will be, the result is big of